To start today, we're going to have Scott Fouse come up, who is the Vice President of Advanced Technology at Lockheed Martin, that obviously has lots and lots of advanced technology. So, Scott, I'll let you do your thing.
Thank you, John. And I want to add my welcome to everyone here. You may not know this, but the group I run at Lockheed Martin Advanced Technology Center, we've been here over 60 years. So we made our way, opened up our shop here in 1956. I also want to thank you for the opportunity and actually, where are oh, there it is. For the opportunity to talk to you and give you some of my perspective about innovation and also what Lockheed Martin is very focused on right now, which is this kind of convergence of military and commercial markets. And I'll talk some more about that. One of the things I want to do, though, is I want to talk a little bit about my personal experience. So I actually started my career in aerospace. You know, I won't say the number of years because I don't need to make myself feel that old. But I only lasted there 7 years because I got the itch. I wanted to go off and try some entrepreneurial things. So essentially, well, I was lucky because I was able to start a small company. And that small company ended up doing advanced technology research for the military. John just mentioned kind of the machine learning. My company was focused on artificial intelligence. So, and that was actually a term back in the 80s that was a little bit of a bad term back then. People will remember there was this thing called the AI winter. But my company was very interesting because we ended up making a living on helping to develop advanced technology and see a transition into the hands of real users. And when you know that you're trying to save lives, this transition thing becomes very important. And so we learned a lot about that. And that's one of the things I want to talk a little bit about kind of my views on innovation. And one of the transitions got to be so important that it caught Lockheed Martin's attention. And so Lockheed Martin, 10 years ago, decided they needed to buy us. So after running a small company of about 50 people for a while, I got to, enjoy the benefits of a very large corporation, and it turns out it gives you a completely different perspective on the world. So, and as we talk through this, it's it's really this challenge of how do you develop revolutionary technologies and then hand it over to users where it can make a real difference. And that's a non-trivial thing, and that's part of what I want to talk about in terms of the some of my experience. So first off, I'm going to talk about my innovation perspective. So everybody talks about innovation. I'm going to just talk about from my perspective. And one of the things we discovered early on, and we would develop some new tools, you'd hand them to the users, and the first thing you would find out is once they start using it, it would change the way they do their job and the way they think about their job. So it means I can't ask the users for the requirements. They don't know. And the question is, how do you now start to project? You essentially want to solve this problem, the Wayne Gretzky quote, I want to skate to where the puck's going to be. And so the question is, how could we project to the true requirements? And the way we did this is we gathered a group of people, kind of visionary technologists, and married them up with visionary users. And then we immersed them for like 6 months or longer so they understood the domain. They really understood the problem. And then once they understood the problem, we would start this process, and we'll call it a little bit of time travel, start to try to anticipate what that future would look like. And now one of the things that happens when you've got two groups like that, and I've always believed that innovation occurs at the seams. So what do I mean by that? Well, if I have a group of technologists and a group of operators, they each look at the world differently. And when you put them together, those different belief structures create some very interesting friction. Because those different views challenge your own beliefs. And so what happens, the sparks fly. And those are the roots of the innovation. And the problem is, how do you do that and harness it in a way that you can start to anticipate what the future looks like? So that's what we did with these. We were building a big command and control system, and we got these guys together, and when those sparks started to fly, they started to light the way to the kind of those future requirements. And so for us, that's a big part of what innovation is about. One of the things I want to do here is talk some about the kind of what Lockheed's very interested in is this kind of notion that government and commercial markets are starting to converge. And why I'm going back to the sparks fly. When you get two different groups like this, it again creates some very interesting opportunities for innovation. Now, why is this happening? Well, on the government side, we all know US government, the DoD, facing immense budget pressures. So they have to find ways to do things differently. And from our perspective, one of the things we're trying to do is figure out how we can amortize the cost of development of this technology and capabilities over both military markets as well as commercial markets. So that's our challenge, is how do we find, and what we need to do is we need to identify joint projects. That's one of the reasons we're here today. Now, so that's one of the key things that we talk about this new reality is that we have to find ways that address this big affordability challenge. The other thing that happens, though, is, and again, when I started in this industry, it was very clear that technology came out of the aerospace companies and make it their way into kind of commercial. That absolutely is not true today. And that means on the government side and on the aerospace side, we have to change the way we think about this stuff. And in fact, there's great opportunities when we can start to bring the government and commercial sectors together for us to both learn ways to be more cost effective, but maybe more importantly, learn ways for us to be faster and more agile. And because on the government side, sometimes it's a large bureaucracy. And as an aerospace company, we're aligned with that. How do we now find ways to get to that, kind of these new ways of doing things? So Lockheed Martin's trying to recast itself so that it's able to operate in this kind of new reality space. Now, what I want to do next is talk a little bit about some of the examples where we're doing this in real time. We are doing kind of joint military and commercial projects. And so I'm going to highlight 3 of the projects we're doing in our lab right now. So I don't know if people have heard of graphene. It's a very interesting 2-dimensional material. And we've got a bunch of material scientists in my group. They're very excited about that. And one of the things they said is there are they started thinking about, what if I could actually drill microscopic holes, angstrom-size holes, in a piece of graphene, and start to look at how it could be used for doing separation technologies. So originally when we were looking at it, we were actually looking at some very specific applications in the military and space. For instance, inside a space capsule, you need the problem of you've got to be constantly cleaning the air system. So that was the original application. But it turns out there's huge other opportunities, and especially for water filtration. So a lot of interest in that, as well as any type of gas or liquid filtration. So this is one of the areas right now that actually it's getting a lot more interest in the commercial sector, and so our folks are now focused on that. And as we get more traction in selling into that commercial market, we'll be able to take some of the results from that and then move it back into our military applications. One of the ones I'm actually quite excited about is this thing called nanocopper. So we've all heard of nanotechnology, and I think the popular people know a lot about carbon nanotubes. We had one scientist who said, well, are there other materials that I can work with in this kind of this nano form? And so he was fascinated by it, and he discovered a way of taking copper and putting it into a paste where it actually is able to kind of exist in this nano form. Well, what does that mean? Well, it turns out that in that nano form, you can bond with this copper, nanocopper, at 200 degrees C. You understand, copper melts at 1200 degrees C. But if you can bond it at 200 degrees C, then you can could imagine I could replace the solder I have today on all my boards, and you use real copper instead of this lead-based solder. So why is that important? Well, for space applications, there were some real issues with solder and what they call these tin whiskers. But what's fascinating about this is the first time they've had a bonding technology where it bonds at a temperature significantly cooler than that it will operate at. So I can bond at 200 degrees C and it will be able to operate all the way up to 1200 degrees C. So in this case, we've got a lot of military applications, but what we're going to be doing is, in fact, what the near-term applications are going to be in the area of high-power LEDs. These you just look at LED technology all around us. They want to get more and more brightness out of it. It turns out this is going to be a key technology to enable new display technology. And the last thing I want to talk about is Spider. So in the first two cases I explained, the innovation started from a kind of a military-based application. This one, what Spider is about, and I'm going to show you a video, is about doing imaging without using lenses. So, and from a space application, this is big, because to create images, I need to be able to use a large piece of optic, which is heavy, large, expensive to make, takes a long time to make. Well, we had one of our scientists who's very much into imaging, and what I want to do right now is show the video so you get a chance to see.
As biological beings, what we do is we collect light and then re-image that light using some sort of optical system, a lens like is in your eye or a telescope. That's certainly the simplest way to form an image, but it involves bulk optics for transporting the light and moving it around to form the image. And when the size of that aperture starts to get large, that completely dominates the sensor in terms of its size and weight and how much power it consumes. And there's a huge cost associated with that increase in size, weight, and power. Spider is a new way of collecting light to form images. So interferometry is just a way of doing that. It's a way of taking light that's collected at two different places and combining it directly, interfering it, and it forms what are called interference fringes. Much like, if you have two waves in a lake that are interfering with each other and overlapping and forming these standing waves that you might have seen. So we collect the light, couple it into this silicon chip, move it around and combine it in a way that we can measure it with just ordinary detectors like you would have in your cell phone camera. And then take all of that data that's collected by those detectors, process it in a computer, and form an image. It's just a simple disk, and the disk itself is just made of silicon chips, very thin chips. And so it only scales in 2 dimensions. To have the same performance as the telescope behind me would have to have the same diameter, a meter diameter, but the thickness would stay the same.
We do all the operations on the light in the circuit instead of bouncing back and forth between mirrors. So it's just a way to shrink everything into a much smaller and lighter package.
For the Spider program, we're partnering with the University of California at Davis. And we picked them to work with because they have the unique expertise in designing and fabricating these kinds of photonic integrated circuits.
By working with Lockheed Martin, we were excited to make photon integrated circuits that are more functional but more compact. Our first generation photon integrated circuit was about the size of this palm. The second generation photon integrated circuit is about the size of my fingernail. It has about the same number of devices and same amount of functionality. Now, the third generation photon integrated circuit will be utilizing what you see in my background. It will utilize the 3D printing technology with the photon integrated circuits being written with the laser inscription, so they can have even higher density laser waveguides on a very compact volume.
Spider could offer the ability to do things we simply can't do today. It could offer a lot of commercial, terrestrial, and defense applications as well. Anywhere there's an optical imaging system, there's the potential to take advantage of this technology. We're very excited about being involved in the beginning stages of a project like Spider, that has the potential to completely revolutionize the way imaging systems are built in the future.
We're trying to do something exciting and something that can change the world, and I think this technology prompted by Lockheed Martin is going to change the world in the future.
And so that's an example of a technology that's going to revolutionize how we do imaging. So thank you very much.